So from an OS perspective, the files are essentially organized in terms of a file system, right? And the volume is essentially used to store a file system. So a volume could be present in multiple partitions, it could be across different disks or within a single disk and so on. So for instance, this is how a particular example would look. So you have a file system comprising of or a volume comprising or spreading across multiple partitions like partition A, partition B and partition C. Each of these partitions have their own series of directories and the corresponding files. So what we also see is that this volume is spread across disk 1, disk 2 and disk 3, right? So it's associated with multiple disks. And yeah, and okay, volume contains and as mentioned, volume contains directories which record information about the name, location, size and type of all files on that particular volume. So the within the file systems, the directories are essentially critical because this essentially takes us from and helps us connect the root directory to the various files. So the directory essentially maps file names to locations on the disk, and there are different ways these directories have been organized. So the older systems had the single level directory or the two level directory. So single level directory essentially is the simplest form, where there is just one directory and all the files are essentially present in that particular directory. So these could essentially result in problems, especially when there are multiple users that are present. So multiple users may end up creating files within the same directory which have the same file name, and this could essentially create a problem while trying to open files for access, right? And thus a restriction with a single level directory is that all the files should have unique names. The two level directory structure solves this problem to a certain extent. So for instance, with a two level directory, each user is given one directory, right? But it's still not very flexible. So what is currently done is that these directory structures are typically tree like, are structured as a tree. We have the root directory which is at the top of the tree, and below this we could have several other directories, and within a directory you could have other directories present or files that are essentially stored in that particular directory. So for example, here in the root directory we have three subdirectories called spell, bin and programs. Programs, for instance, is a directory which points to which has three directories again, P, E and mail. So mail has a single file, while P and E have another layer of directories. So for instance, if I have this particular file as, let's say, x.txt, then reaching this particular file from the root would be through the root /programs/e, then count and then x.txt. So what we see with this particular form is that each file has a unique path from the root, right? The second thing is that it also gives the flexibility to have similar file names. So for example, I could have an x.txt stored in a different path from the root, and the operating system would be able to distinguish between the two files, right? So especially in a multi-user system, such hierarchy of directories is essentially useful. Now, so this directory structure as well as the files are essentially stored on the secondary storage device. A bit in the file name, a bit in the file system entry or the inode is essentially used to distinguish between a directory and a particular file. So there are also special system calls to read, write or create directories. So directories can also share files. For instance, in such a case, I have two directories, root, dict, and count, which is essentially having this file called say x.txt, and the same file can be also referred through root, spell, words, root, spell, count, and x.txt, right? So this is essentially useful in certain cases when files need to be shared between multiple directories. And the way to essentially achieve this is by using links. So there are two ways links can be used. For example, here are the hard links and the soft links. So we'll essentially take an example of this on our system. So let's essentially show how these links are created. Let's create a file called x.txt. So what we'll do is we'll create a file called called x.txt, and in that we will put the string hello world, right? So now if I essentially look into my directory of called slash tel, this is my home directory, slash tem and links, I see x.txt, right? And more information can be obtained like this. It also gives me information about who created this particular file. It also tells me the permissions of this file. Now what these RW essentially means, we'll get into details and much sometime later. And it also tells you the file of time of creation. So what we will do now is that we'll show how the same file can be accessed through different types of links. So as we see in this particular slide, we could create soft links. So let's create the soft links first. So what I'm doing now is I'm creating a new directory. If I do ls here and list the files present in this directory, I see that it's nothing. So I could essentially create a link to x.txt as follows using the command ln -s. So the -s stands for a soft link. I point to the path of the file, which is x.txt, and create my link here as xsoft.txt. Okay, so now I've created a file here, and if I look at the contents of this file, I would see the same. I would essentially be reading the same file of x.txt, and any changes here in the file x.txt, like for example changing it here, would also reflect in the xsoft.txt. Okay, right. Now the problem with these soft links is when the original file essentially is changed or renamed. For example, if I rename x.txt to say x1.txt using this command x.txt to x1.txt, and I see here, what I actually see is that the file is renamed. The contents of the file can now be accessed through x1.txt. However, when I look at the soft link and try to access the same file through the soft link, it is no longer possible, right? It says that the file is not, no such file or directory. The reason is that the soft link that has been created is to the file x.txt, which now is not present because it has now moved to this new file name called x1.txt. The solution for this is to essentially use hard links. So let's try creating links to x.txt using hard links. So we'll create a hard directory, and we'll use this command ln x1.txt and x hard dot text, right. So as before, we have essentially created a link x hard dot text through which we'll be able to read the contents of the original file x1.txt. But the difference with the hard links is that it will also persist even if the file name is changed. So, for example, changing x1.txt to say x2.txt as follows. Would not affect the link. So, here our link essentially persists still. So, there are certain advantages for hard links and soft links, and there are certain applications for each of these, right. So, while we see the benefits of hard links in this example, hard links cannot essentially link to directories. It cannot also link through to across different file system boundaries, while soft links can essentially do both of these. Hard links always refer to the source even if it is moved or removed. This is what we've essentially seen. But soft links are destroyed if the source is moved or removed, right. So, these are the subtle differences between hard links and soft links, right. Now, one thing which we've also seen, and an important aspect of files present in a file system, is the aspect of protection. So, every file is associated with some access rights. So, these rights are essentially read, write, or execute, and it determines whether the file can be read, written, or executed. It also has properties as like the user or the owner of the files, uh, and it defines who is the user of this particular file, and it also classifies files into different groups. So, these groups and these users are used to decide whether permission should be given for a particular process to access a particular file. So, associated with every file, as we have discussed, is the inode uh, and the metadata for that particular file, and it is uniquely identified by an inode number. Now, the inode number for a particular file can be obtained by using the ls -i command, x2 minus text. So, this number here is the unique identifier which is used by the operating system to refer to this file x2.txt. So, notice while this name x2.txt is a readable format and very understandable for users, the inode number on the other hand is just a identifier used by the operating system, right. Now, the interesting aspect is that when we used hard links, this inode number is going to be remain the same as the original file, right. So, we see that in both cases 499,57356 is the inode number for the hard link as well as the original file x2.txt. However, when we go into the soft link and try the same, we see a different inode number, right. So, so this is a characteristic difference between hard links and soft links.